Okay, welcome back to Pong. Here's where we were in the last video. We have a functioning game, but we have a lot of mistakes, a lot of issues with the game, and we're going to try to fix a lot of them today and add some further functionality. So here's what we are going to try to get done. So first we want to change the sizing parameters and add the center line. And so last video I mentioned that you guys can mess around with some of these parameters and see what works for you. Well, I've done that, and I'm going to change them now. So first thing let's do is change the frames per second to 100 just to make the game more smooth. We'll change the left from 50 to 25 to keep it symmetric. We got to change the right, and we'll change the top from 25 to 35. And again, to keep it symmetric, we'll change the bottom to 565. Going down, we want to change the ball radius to 10, and we'll be doing that in both the shape attribute as well as when we draw the ball in the draw method. And continuing to go down, we want to change the ball velocity to 700 and negative 300. However, there's one problem with this. Let's go ahead and run this now. So every single time the ball restarts, it's going to restart at the same direction. And we want to randomize the direction at least a little bit. For instance, if I change the sign right here to negative 700, then after the first one, of course, because the first one is occurring within the init method, then we're going to go the other way. So we want to randomize that. And so anytime in Python we're randomizing anything, we need to import the random module. And one thing we can do is we can just multiply this value by random.choice. Random.choice just selects a value from a list randomly, and we'll say -1 and 1. So that'll randomize the sign of the velocity. So let's go ahead and try this first. And we've randomized the direction, at least up to one of those 4 directions. But the first time the ball runs, it still runs with this initial velocity we give it in the init method. I don't think we need to do that. I think we have this reset method that we can run in the init method. So let's go ahead and do that. Self.reset. And we're gonna have to give it something random for space arbiter data. Remember, we have these parameters in because of the collision handler, but in this case, we'll just give it something random, zeros or something. So we have a random direction among the 4 possible directions. So we'll keep it at that for now. Going down, I wanted to change the wall thickness to be 8. And we'll have to do that in the draw method as well. And going to the player, let's change the player thickness to 12. Let's also change the size of the player from 30 offset from position to 50. And again, we have to do this in draw. Now, luckily, because of the local to world function, we don't have to change the positions themselves. And we want to change the move velocity. So this is every single time I press the up or down arrows from 600 to 800. I think it'll be a little bit faster. And going down the code, I don't think there's anything else I wanted to change. So let's run this. Okay, I think this looks a little bit better. Now let's see what else we have to do. We have to add the center line. Okay, in the last video, I kind of lied with the thumbnail because I had a line up the center denoting the center of the screen. And I forgot to do that in the last video, so let's do that now. So we can draw this right after draw. Note that I don't want to make an instance of the wall class for this because I don't want the center line to actually be a wall. I don't want it to participate in the physics of the simulation. So we can just use the pygame.draw.line function. And so we need the display here, the color, which I'm going to make white. And we'll need 2 position arguments. So the first one is going to be, we'll just do the top. So I'll say, in regards to X, it'll be middle X and then top. And then we'll have middle X and the bottom. And then we have one more argument, which is going to be the thickness. I think 4 is a good value for this. So let's run this. And now we have the middle line. So this looks pretty good. Now let's see what else we have to do. We can cross this off our list. Our next step is we're going to prevent the players from moving too far off the screen. So here's what's happening right now. Player 1 and player 2 for that matter can move all the way off the screen, and we want to keep them constrained within the playing field. So let's figure out how we can do that. One thing we can do is right here where we decide if we want to move the players or not. We can only do that if and we're going to write a method for this called, let's say, on edge. We should say if the player is not on the edge, then we can move the player. So, of course, we're going to have to write this method on edge. Okay, so let's go ahead and write this method in the player class. I'm going to write it over here. Define on edge. So let's check the top edge first. So if self.body.local to world again, self.shape. And then for top, it's going to be the first one because we just happen to put in the first one as the higher point. So self.shape.a. So if this is less than or equal to top, then we want to do two things actually. We want to stop the thing from moving, stop the player from moving. So self.body.velocity equals 0, 0. And we also want to set the position to the edge, right? The reason we do that, so self.body.position is if in the simulation the player goes over the edge, then we don't want to have the player stay there. We want to bring that position back to at the edge. So we can say self.body.position is going to be top. However, it's not the position because the position's in the middle of the player. It's going to be the top edge that we want to be at the variable top. So we can say top plus and then 50 because 50 is going to be the half player size. So we really probably should have had these values be a variable, but that's okay. Okay, and then so the same thing, but for the bottom. And let's fix my indentation. Okay, and so instead of point A, we want point B. We want this to be in case it's greater than or equal to bottom. And then not top plus 50, but bottom minus 50. All right, let's run this. And what happened here? Okay. So when we set this, we can't just set the y value for the whole position. We need the x and y value. So we can say self.body.position 0. So this is because we didn't save the x value of the player. This is just one way of getting the x value. Okay. And that's still a problem. Okay. When we're checking to see if the position is less than or greater than a certain value, we need to check the y position, not both of them at the same time. So let's try this. So now we're able to move the players without moving them off the screen. Okay, so we can cross this off our list. So next we want to update the balls in it with reset method. Actually, I already did that, so we're good here. So standardize the ball's velocity every hit. Okay, the reason why I say we need to do that is there comes a time where if you hit the ball on the edge of the player, sometimes it kind of, there we go, sometimes it kind of just freaks out. So let's understand why that's happening. So the players are these kinematic objects that have an infinite density, infinite mass. And when an object of infinite mass runs into an object that doesn't have infinite mass, it's going to transfer a lot of momentum to the ball. So that's what's happening. So one thing we can do is every time the ball comes in contact with the players, we can just standardize the velocity to a certain value. So let's go ahead and do that. But before we do that, I think it's valuable to review a little bit of vector mathematics. So here's our XY display, and remembering that the XY starting points are on the top left. So let's say we have this ball, and we currently have a vector that represents its velocity. So the length represents how fast it's going, and the direction represents what direction the ball is moving. So we have this set up with an X component of 700 right now, and a Y component of, let's say, negative 300, negative because negative is upward in Pygame. If we want to slow the ball down or increase the speed, we increase or decrease the length of this vector, but not necessarily the direction. So for instance, if we decrease the speed of this ball, then we can do so by keeping the ratio of the X and Y components the same, but just changing the length or the magnitude of this vector. So let's go ahead and do this. Oh, and one more thing I have to show you is when we set the velocity or the position of the body, it looks like the body's velocity or position is just a tuple that we give it, but actually Pymunk has its own class, its own object called the vect2d object. So this is the documentation for Pymunk, which is in the description. So let's go ahead and learn a little bit about the vect2d object. So as you can see, this is kind of how we manipulate the vect2d object. And as it says here, Pymunk is smart enough to convert tuples or tuple-like objects to vect2ds, which is what we've been doing. So we want things like the length or the magnitude of this vector. So if we go down here, we can find that there is a length attribute to the vector. So we don't actually have to calculate this ourselves. So going back to our code, we want to create a method that standardizes the velocity. So we'll say define standard eyes velocity. So we can set our self.body.velocity to a scaled version of the current self.body.velocity. And we can scale it by the velocity that we want. So I'm going to say, I think 750 is a good value for this, divided by the old magnitude or length of this velocity. So that would be self.body.velocity, which we saw was a vector2d object, which has an attribute called length. Okay, so when do we want this method to run? Whenever we come in contact with the player. So we need to create another collision handler. So I'll say contact with player equals space.add collision handler. And so we'll have our ball be the first collision type. Oh, and we have to set a collision type for the players. Let's set it at 100, something kind of high. Now what integer we use doesn't actually matter as long as we keep it the same. And within the player class, we'll create a collision type. So self.shape.collision type will be 100. Now, what we did for the scored collision handler is we used the begin attribute. Actually, in this case, we cannot use the begin attribute. And let's learn a little bit more about the collision handler. So going back to the documentation for Pymunk, we can find the collision handler. And it says right here that a collision handler is a set of 4 function callbacks. So you have begin, which is what we used before. We have pre-solve, we have post-solve, and we have separate. So begin happens right when 2 objects touch each other. Pre-solve happens right when the 2 objects' collision analytics are about to be calculated. Post-solve happens right after the collision analytics are to be calculated. And separate happens when the 2 objects stop touching each other. So we need either post-solve or separate in this case, because we want to standardize the velocity after the ball hits the player. So going back to our code, we'll say contact with player dot post-solve equals ball.standardize velocity. And I just realized I put this standardized velocity in the player class. We definitely don't want that. We want to put this in the ball class. So go ahead and fix that. And I'm going to copy and paste over here into the ball class. Okay. So I think we're ready to run this. And let's see what happens. Ball object has no attribute standardized velocity. Standardized velocity. Standardized velocity. Okay, so now let's run this. And oh, that's a problem. Oh, if we're going to use the collision handler, we're going to have this space arbiter and data parameters. All right, and now we shouldn't have a problem with the ball velocity changing on the contact with the players. Okay, let's see what else we need to do. We can cross this off our list. Now let's keep track of score. So I think the first thing we should do if we're going to keep track of score is in the player class, create a self.score attribute, and we'll start at 0. And when do we want to increment this self.score attribute? We want to increment it when it hits either the left or the right wall. So right now, there's no differentiation in the collision handler, whether we want to hit the left or the right wall. It's just either the left or right walls will trigger this collision handler. So we're gonna have to change that. So let's change the collision type for the left wall to be, so left wall is when player 2 wins. So 102, I'll call it. I could have just kept it at 2, but I like 102. And remember that this argument goes into the wall init method as the collision number, and then we set the collision type that way. So it makes this a little easier for us. And we'll set the right as 101 because for player 1 winning. Okay, so scored, we're gonna say scored 1 for when player 1 scores, and we need the ball and the right wall, which is 101. And we need a scored 2, which I'm just gonna copy and paste. And it'll be with 102, the left wall. And in regards to passing a function to the begin attribute, well, we have two things that we want to happen every time we score. We want to increment the player.score attribute, and we also want to run ball reset. And we can't give the begin function two different things. So what we should do is write another function that has those two things in it, and then just pass that function. So I'll say define player 1 scored, and we can say player 1.score plus equals 1, and then ball.reset. And what we can do is then pass in scored 1 begin attribute player 1 scored. And we'll of course have to do all of this for player 2. And change everything from 1 to 2. Okay, so let's try this. And I made the same mistake again. Anytime we use a collision handler, we need a space arbiter data. Can't forget these. Can't forget these. All right. Okay, let's run this. And okay. So this reset method does have the space arbiter data parameters. So that's getting a little bit annoying. What we could do actually is within this standardized velocity space arbiter data parameters, we can just give it a default value. So that way, if we don't feel like putting it, we won't. And no, not just in standardized velocity. We want to do this in reset as well. So up here, that makes life just a little bit easier. Okay. So now we should be able to run this, and I promise it'll work. So, okay, we still have more errors. So this is why I shouldn't be promising anything. Okay, we need to pass a Boolean value anytime we have a collision handler function that we're going to use for the collision handler. So remember, we need space arbiter data and a Boolean if it's a pre-solve or a begin. Return false. All right, now it should work. Yeah, there we go. So I guess the score is incrementing now. There's really no way for us to know that unless we print the score on the screen. And so that'll be our next step, is printing the score on the screen. So unfortunately, in Pygame, printing text is not as simple as printing shapes. It's not a one-line process. It's actually a three-line process. And I'm going to do this in a function outside of our game loop. So maybe up here, right before ball class, we can say define print text. And what's going to be different among the two texts we print? So I'm going to print two different texts for the two scores. The text itself, so what the words we are that we print, and I guess the exposition. If you're doing this for a different game, then whatever is going to be different for all the stuff that you print your text for, then you can have that as an argument. Now the three things we need is going to be, we need to create a Pygame font object first, then we need to create a Pygame surface object, and then lastly, we need to add that surface object to our display. So to create a Pygame object, we'll say font equals Pygame dot font dot sys font. So this comes with 4 arguments. The first one being the name of the font that we want in a string. And I like Algeria, or Algerian, I think it's what's called. It looks the most arcade-like for a game. Size of the font, so the font size, and we'll try 20, and we can change this later if we want. And then bold or italic is going to be Boolean values and whether we want them to be bold or italic. So I'll say true for bold, and then maybe false for italic. The next object we want is going to be a surface. So I'll say surface equals, so the surface can be created from a font method called font.render. There are 3 arguments to the render method. First is the text that we want to write, so I'll say text. Second is a boolean, whether we want rounded edges on the text, and I'll say sure, true. And the last is going to be the color of the text, so we can say white. So 255, 255, 255 is the RGB for white. Lastly, we want to add this surface to the display. So we can do that with display.blit. And there's 2 arguments here. First is the surface that we want to add to the display, and then the location. And so I'll say X, and I think let's try 5 for the Y. Unfortunately, there's really no better way of writing text to a Pygame screen. So I'd recommend just memorizing these 3 steps or writing a function like this every time. So going back down to our game loop, we can now print text to the screen. So use the print text function. And I will say for the text, we'll use an F string. F strings allow us to write executable code within a string. And so we'll say score equals, and then within the curly brackets is where the executable text occurs. So I'll say player1.score. Player 1's on the left side, so our X position we'll say is left. So let's try this. And we have our score, and it's incrementing properly. So we'll do the same thing with the right side. Now, I want to mention that in this text function, where we give it a position, that position, if you haven't noticed already, is the top left of the surface, which is our text. So the top left. So why that's important is when I'm writing the score for the player on the right, which is the player 2, we have to be a little more careful about where we put our X position. So let's try this. So player 2 score right, and it's a little bit off to the screen. The reason for that is because we provided the top left position. There is a method that we can use to get the length of a surface and use that to subtract back. I'm not going to bother. I'm just going to do guess and check. So let's try minus 50, and that's not enough. Minus 100, and that's almost there. I kind of want to line this up. So let's do minus 120. And no, still didn't do it. So let's try minus 110. Okay, so we'll keep it at that. And now we have the score. Okay, now let's see what else we have to do. So we can keep track of score out, and then change the name of the Pygame screen. So that would be great. So what I mean by that is right now we just have this called Pygame window. It's kind of silly. There is a way to change that, and it's very simple. So let's go all the way up to the top, where we create our Pygame display, and then right after it, Pygame.display.set caption, and I'll just say Pong. So let's run this, and the caption shows up. Okay, so this is our thumbnail, so that means it's time to stop. So we're gonna have one more video in this series where I'm gonna add a little bit of fun stuff that we can manipulate with this game, just to get us more practice using Pygame and Pymunk.